Amen.
Okay. Welcome, gentlemen, to our Friday course, which is with a purpose. And one of the purposes is the construction work that will be going on around making bricks with their Buildwork Solution, our partners. And on this program, which is part of the Professional GCSEs, today we are going to go and start looking at the construction side of things as announced. And today we have got Arthur. At least you've seen Arthur on the screen. He's going to take us through the construction aspects. All the best that he knows, he will introduce himself. And I know many of you are coming from the construction background, you're builders, and all the best that you know. So without much ado, I would like to welcome Arthur, and let's go straight into the lesson. Arthur, you are free to share your PowerPoint, whatever it is.
Hello.
Yes. But there's Arthur. Arthur is going to teach us what he knows. Make sure after he presents, as interactive as you are, you can ask questions. So Arthur.
Okay, thank you for the introduction, John. So I will say that most of my training is done in person. So this is my first webinar presentation beyond that of a meeting. So you'll have to forgive me. I'm quite an interactive person with my hands, being a builder. So yeah, well, I'll get started. So I've been building pretty much all my life. I studied engineering in Salford College, which is in the north of England, next to Manchester, the famous football teams, you know. And I've been working with Buildwork Solutions for a long time now, over a decade, back when it was even called Harry Building Products, which you may have heard the name of. So I've been lucky enough to have traveled all over the world doing these projects, really focusing on concrete quality in terms of product design with blocks, tiles, whatever it might be. Also finding gaps in the market and how to get the finished product to the market for then to create a revenue. So that's something that I've been involved in, quite proud of a few successful projects around the east of Africa in Uganda, especially. We set up a workshop there with a family. Running now, they broke even within a year, and now they're profitable. Then with the revenue funding back flowing into the family business, they have built their own house. So it's kind of a circular kind of program that Buildwork Solutions kind of aims to achieve. So I have been into Zambia twice before with two different organizations, not to do with the block work and the concrete production that we're going to talk about today. I was there with Build It International. I don't know whether you've heard of them. They operate in Kanyama and Chabolia in Lusaka Central. I was also working with Hope Worldwide Zambia. So they were another one that did a partnership affiliation. There was a project up in the northern region of Zambia in Ndola, and I was in the bush there doing some hydroform blocks, which you may be aware of, the sort of soil stabilized blocks where you use some soil, add some cement, and then it creates a strong final product. So I'm going to briefly outline now what the course will entail. And I'll probably go over the top in terms of detail with the concrete and different design elements that our system uses, purely because of the fact that if you know it, it's useful to then try and consolidate some knowledge that you already have. In terms of me teaching you skill, as I've been told by John, many of you are masters in what you do. You've been doing it for years and decades. I'm not going to try and teach you how to build because you know how to build. All I'm going to do is kind of give a few new ideas and kind of show some of the designs that we use to make a cheaper building, which has the same strength. So where my specialities, my course will cover is sort of the basic construction in terms of laying out, quantity surveying, ground evaluation. But a lot of that won't be that vital for you. Having said that, if there are any topics that you want me to really delve deep into so that you can increase your knowledge, your scope of understanding, I'm happy to do that. There's been a few occasions where gentlemen have said to me, I really want to know how to accurately work out foundation depth depending on soil types. I imagine in Lusaka, the region you're going to be working in, the site you're working in, it's probably going to be some laterite, some murum, something like this, which is very high clay dense soil. So that normally means that there's a lot of expansion and contraction in the ground, which I'm sure you know from the water leaching from the rain, leaches out the silicon, and it leaves this red irony look to the ground. They're all considerations in building. There's lots and lots of considerations to kind of take into account. But really, the concrete theory in making good, strong concrete products is what we will be hyper focused on. The building construction, that can be like a beneficial add-on. And then the design of the structure we use, called the high and dry system, will be then like supplementary. That will be the end. That's the assembly of. So, but it all starts, excuse the pun, at the first block. You know, it's like you need the foundation strong to then be able to move on with a strong building. Because if we have weak blocks, especially because they're going to be handmade blocks, so they're hand casted molds, which means that they need to be straight, they need to be plumb, they need to be level, and in that way we can ensure the building will also reflect the quality and the effort that's put into the production of it. So I'll briefly now outline kind of what the concrete theory element of the course will be. It's going to be the ingredients, the aggregates, how to test them. We're going to be doing quite a bit of testing just so you can understand what's good and what's bad. Even some things like being able to read the cement gradings properly with all the different little numbers and letters and what that all kind of represents. The ratios that we're going to be using and how that reflects in terms of concrete strength for the final product. Because we all know that messing around with the recipe of concrete affects it in certain ways. But what I'm really going to do is kind of show you how and explain why it affects it in different ways. There's a common myth that more cement means more strength, which is not entirely true. In some cases, yes, it can be, but you get the compressive strength from concrete from the aggregate, the stone. That's what we call like the coarse aggregate, the rock, the gravel. That's what gives concrete its strength. So if you just keep putting more and more cement into the mix, one, it's very costly and not very economical. Two, it's not actually giving much more strength for what you're putting into it. You can better use your time and use your mind, because if you've got the skills already, all I'm going to try and do is trying to make you think about things in a certain way where you can use those skills to best get the most out of what you're doing, in terms of saving money, saving effort, and then you can build a reputation of being the guy who knows a little bit more than the neighboring competitor, you know, the other guy who does the same thing. You know a little bit more about what you're doing a little bit better, but just from the knowledge side of it. So again, I'm not going to try and stand on anybody's toes. I'm sure you've all, well, many of you have been building for a good length of time yourselves. So we'll be moving on from there in terms of how the vibration machine actually works and how that embeds the aggregate, gets it fully covered in the cement paste so that it's a nice coherent substance. It's a nice strong all the way through. There's no point in having a little bit of a concrete core or a concrete product strong, but then another part that's not so strong, because all that will happen is, as we know, it will break at the not so strong part. So I'll be going through that, and then the chemical processes that are involved in some of the like sulfate attacks and different things that can happen to concrete and kind of make it weaker. That kind of links into the water ratio, how much water you're putting into it. So I understand that John has a mixer, which is very, very good. I cannot recommend them enough, because to get the proper mix of a good concrete, whether it be like a cementitious material like mortar, still needs to be well mixed, but concrete especially needs to be very well mixed. And to do that by hand, to get it fully mixed and get a good workability, a good flow into it, it takes a lot of effort, especially if you're doing big projects, big pours, you know. So to have a mixer to do that is I think vital, because otherwise what can happen is people, to make it more workable and make it easier to mix and give it more flow, they add more water. But what this does is it makes less dense concrete. It means that when the water does finally evaporate, then there's bigger tubes. All concrete has pores like skin, but there's bigger tubes that go deeper into the concrete because you put that extra water in. So what I will do is it will really ruin your concrete's durability in terms of the lifespan of the concrete. So what we're going to be trying to do is we're going to be achieving 100-year concrete. That's my goal. That's what I tell people. We're going to try and I'll give you the knowledge to make 100-year concrete. When you've got the skills, we'll put them together, and then that's the plan. That's where we're going to be heading to. So that will include the states of hardening concrete as well. It sets and hardens at different times, as I'm sure many of you know. And during those phases, curing is imperative. Curing being covering it in water. Lots of different techniques of curing. Some are better than others, depending on climate conditions. But the ideal one is just make sure it's wet and make sure it's out of the direct sunlight, because the direct sunlight is not your friend. And it's not your friend because working in it can destroy your energy. It saps your energy, but also it's not concrete's friend either, because it does the same thing. It sucks all the water out of the concrete before it's done, before it's properly cooked. You know, the hydration process hasn't finished. It's not got its ultimate strength, and you're losing money because of that. So I tell road block side makers, like, I'm creating concrete blocks with people with the vibration machines, but I've befriended people in Nigeria, it was, and one of the fellows there said, "Oh, I'm in concrete." I said, "Oh, no way." He said, "Yeah," and then I just told him this thing. I said, "You're losing up to 50%. This is scientifically done in laboratory conditions. 50% less strength for the concrete blocks if you let them just dry naturally in the direct sunlight." High heats are bad for concrete. Best range is like 10 degrees to 22 degrees. So anything over 22 degrees centigrade means that it's going to really, really damage the concrete. So you're getting 50% less strength for the same amount of cement. So it's the same cost, but less strong bricks. All you need to do is wet them and cover them. So when I told him this, he's like, "Oh, no way." I was like, yeah, you're wasting money, man. You're throwing money away when it doesn't need to be. So that's what we'll be doing. We'll be doing testing and different improvements. I by no means know everything. I am always learning. So if there's things about construction that you think, "Oh, okay, we can maybe do it like this," I'm always open to improvements and different innovations on how to do a task. I think it's foolish to think that you know everything. And this is I'll be coming to your country, so I'm going to be although I've been there a couple of times before, this is your turf, so I do appreciate that. So on top of that, we'll be getting onto some engineering forces, like the forces behind what stresses our concrete, what we're fighting against. Sort of the objective of making tall buildings is making sure everything's stable and in equilibrium, and being able to withstand those stresses. So that will really come down to the tensile forces, the compressive forces, all these different things, shear forces that are coming in. So we will be doing some engineering for anybody who really wants to go deep into that. We can certainly go deeper into that, because it links into the system that we'll be using with the high and dry system. So our system really goes on a concrete reduction, which means we won't be using the conventional 6-inch floating suspending slabs with the rebar mats. Instead, we'll be using carefully positioned rebars going through valleys that we have created out of prefabricating different modular units of waffles, which will give us formwork underneath, precasted formwork. So you make your waffles, you cure them, you make them strong. We'll go for I don't know what the timeline in terms of we'll be working with when I'm there, but we can certainly do demonstration buildings with some of the guys who really want to take on this knowledge with how the high and dry system works, and we'll do some demonstration buildings. We can pour the concrete. That's all fine, but as we'll get into, and as I'm sure you know, the concrete doesn't doesn't set straight away, doesn't get hard. There's different times that we talk about the strength of concrete. So you get the 7-day strength, you get the 14-day strength, and then finally the 28-day strength, which is when we stop really referring to concrete as getting stronger. We say it's the ultimate strength. Technically, concrete gets stronger constantly. It never really truly finishes setting harder and harder. So I don't know if anybody has been working on old buildings, but trying to cut through the old concrete is so hard. It's because it's just been hydrating and solidifying more and more and more. And this is one of the reasons why there's Roman buildings, ancient buildings all around the pyramids, this sort of thing. They used a version of cement. They used quicklime, which is kind of the ancient knowledge. So it's nothing new that we're going to be kind of doing. It's just more refined because of like this has been going on for 2000, no, 6,000 years. Yeah. So it's slowly become more and more of a science, I think. And think we're trying things. We've got different admixtures. We've got different water reducers, retardants. We can make dyes, make it. Yeah. So there's a lot you can do with concrete in that it's moldable. And so the design is kind of, that's where the building knowledge about the forces and things like that is. If you think, oh, can I do that? And then you'll now have, after the end of the course, you'll have the knowledge, oh yeah, no, I can do that as long as I make sure that this is in place or that is in place, these different bending moments, things like this, counterweighting it to make sure that it's going to be a safe and strong structure, which lasts 100 years. That's the plan. So we'll go through some of the building processes as well. I'm not sure whether John has covered the building processes in terms of the surveying of the land, the water tables, which I know that you have knowledge of, in that John has just hit water as it is, you know. But we'll go into some of that with the composition of the soil, like how is our building going to react against the ground we put it into. And I'll give more than just the environment that the site will be located on, because you might be working in other sites. There might be you might be working in more jungle dense sites where there's a higher organic material. You need to cut through that, and then you see, oh, okay, I'm not really used to this ground. It's darker than it's not the Murram, it's not the laterite. You know, so we'll be talking about that to a point. We'll do plot boundaries as well. I'm not sure what the technology will be available there on the ground, but we'll talk about some of the boundary stuff and what the existing infrastructure is, government lines, whatever waterways or sewage pipes might exist, and kind of how to access that. That'll be interesting for me as well, because when I went to Zambia, the other times I was more of an assistant managing role. Thereby, I didn't have I didn't have any inside knowledge or exposure to the bureaucracy and the building regulations that are required to kind of look into to Zambia. So that's another thing, marking it out, and then installing all the supporting infrastructure that will be vital for the operations and the efficiencies that we want to try and promote in terms of the production of concrete. So that goes from things like making sure the production flow is kind of streamlined as best as possible, making sure all the site preparations are good, and we have some like basic health and safety stuff, because I tell people when they start working with me, if especially the young lads, they want to go at it a million miles an hour, you know, and I'm saying, no, don't do that. It doesn't impress me. They did research into this, and they said that people work in terms of getting the best out of strength and endurance. You know, like this is a marathon. We're building a building here. We're not doing one simple task. You know, they found that it was 70% effort was exerted. 70% is the peak thing you want to do. So I don't want to see people trying to carry too much weight, sweating and killing themselves, breaking their back. You're no good to me. If you're good for a day and then you're broken for 5 days, you're not good to yourself. You're not good to me. You know, like it's making something out of nothing, because what we can do is just approach it a little bit more level-headedly. I mean, ask somebody to carry something with you, and you won't break. You'll be in the game for a lot longer. It's a marathon, not a race. Yeah. And so, and then if you want to try and pick up speed later on, once we got acquainted with stuff, fine. But again, with heavy stuff, construction is dangerous enough. We don't need egos to get in the way of making it worse. So I've covered sort of that bit, and then the building design we talked about to a degree, but we'll be using sort of pier foundations. So there'll be posted foundations, making kind of like a stem wall for the outside, and then building up columns. Now, there's a few different cost reductions that you can use in this high and dry system. So the ultimate one is the one where you don't fill in the voids of the column, but that requires like craftsmanship to a point where everything can be plumb. Everything has to be plumb. Um, Other than that, you can fill it up with concrete and make it into a solid concrete post, more similar to the stuff you will have seen with when you do your formwork and then you pour in your concrete and things like that. Make sure it's tamped down and vibrated to limit any of the voids and really compact and consolidate that aggregate into the material. Make sure it's no voids and pockets and things like that. So the ultimate cost saving really relies on column spacing, and it links into engineering forces as well. But the column spacing is basically where you put your supports, where you put your posts, how far away you need to be, because it works exponentially, the bending moments, on how much you're really kind of stressing out the slab and the concrete. So we say 4.2 meters from centroid to centroid of the columns, or the posts, pillars, whatever you want to call them. And so, yeah, so that means that 4.2 meters, you can make a fairly nice living space, but there's very little in terms of creativity that can be done. That those pillars, those columns need to be there. So that's one level of the cost reductions. But if you go to that level, then you don't need cross beams. You don't need those downstand beams or the hidden beams. It's saving on time, complexity, metal, expenses, things like that. So if you go for the ultimate in the cost reduction that can be done, it will really be just the columns linking into the slab, and the metal works as a mesh. We create a lattice by tying in each of the rebars into the columns, into the foundations, and it's all linked and it's all bound together. And so this is why with that style of design, we need it takes a bit of thought, it takes some precision and accuracy. And yeah, so we'll do some demonstration things on how to do a few of these design modes. It may be theoretical, maybe practical. We'll see how it gets on there. The second version of the cost reduction, which isn't as
So,
cost.
Arthur, can I ask a question?
Oh, perfect.
Just a quick one to see.
Sorry.
We're going with the introduction. So, are we now focusing on a topic now? I'm outside your discipline.
I'm giving the overview of what we've. I don't have a specific topic to teach today. This is more of an introduction and kind of letting people know that what is going to be happening.
Okay.
I don't have the.
So in the next session you do a focus on one of them, yeah?
Well, we can ask people what
Because
they're really interested in, because
you said you're going to talk about high and dry, remember?
well, I was just talking about the high and dry. So that's what that is. The columns and the waffles. That
So
is that's the name that we give to the high and
okay.
dry system.
Yes, I'm just trying to sort of refocus, because it's not everybody in construction, the majority.
Okay.
I think I know there's one or two people.
So what we'll do is this. We'll ask people what they would be interested in really focusing on. As I said, this is simply an overview for me.
Oh, overview. Okay.
Yeah.
Okay.
The high and dry, that what I was talking about then wasn't a focus. That was just me kind of getting into what the product can do, because that's one of the things that's very useful, is knowing how to speak about it and sell it onwards, because not just concrete production, but you're getting an idea out there, and the idea is for affordable housing for people in Zambia who can build the components to make their own houses. So it's a grassroots kind of initiative. So, but to be able to get people behind that, you need to know how to sort of talk about it. So if I start talking about like rebar spacing and different thicknesses of rebars, that's kind of honing in onto the topic. But that's that's not that's not the introductory stage of it, no? Okay.
Okay. Yeah. Carry on.
Well, Okay, well, I'll finish off what I was talking about here now, and then we will we'll ask questions and we'll kind of get to know other people, and then see what they really want to kind of go in on, because a lot of this stuff we can do in the training. So yeah, where was I? So, and then some of the admin, kind of the building management stuff in terms of like the plannings of like logbooks, different quantity material, like write-offs, quantity estimations, that sort of thing, making sure that things are kind of documented. It doesn't need to be over the top, but it needs to be kind of functional and practical, you know, things like having a blackboard where you can put down different stocks and production of what's been made on a day, mark them out similarly, relate them to what's on the actual like factory floor or whatever floor that you're going to be using off. And then different field testing. So the quality control is massive in anything to catch any flaws in a product that might be appearing. So we'll be doing sort of the simple things of going through straight plumb level. We'll be doing slump testing. We'll be going into a lot of things. Material quality control is also something. So it's not just the product. It's making sure that you're not putting stuff in there that's going to be destined to fail, sort of thing. And then, yeah, finally, we'll go over some of the Zambian building regulations that are in place, and kind of what that means, the reality on the ground of how to approach those sort of things, and the procedures that should be taken and can be taken. Okay, back to you, John. Sorry, I'm aware that I've talked for a while.
Any questions? Anybody? Just unmute yourself. Yes, go ahead. Oh, am I muted?
I think according to what he has been explaining, I think it's well understood. Then based on what he's saying that when he comes, that one is going to explain everything. We are going to do it with him. So I'm sure we are going to learn more. Amen. We are going to learn more. And we can't even wait to see him in Zambia, because he's coming will be, amen, will be good. I think we will benefit from him. Thank you so much.
And that's,
yeah, thank you.
Webster's. So you can know your names as well.
Okay, that was Webster. Okay, thank you for that, Webster. It will be a pleasure to meet you on the ground. I know this for sure. I remember some Zambian Yolimba, I think.
Okra. What is it? That's okra.
Oh no, I was trying to say Yolimba, like strength, like power.
Oh, okay.
Oh, that's Nyanja. That's Nyanja.
Oh, okay. Sorry.
Okay, you still remember.
Forgive
That's
me.
very good. I want to the Wolimba.
You thought I like okra too, though.
Good. Another question? Comment?
Yeah, I heard him when he went on explaining about the type of soil.
Well. Say your name first.
Last one, Mkuka.
Yeah. Last one. Okay.
Laston Mkuka.
Laston Kuka. Okay, nice to meet you.
Yeah, last one, Mkuka. So I heard you well when you went on explaining about soil.
Yeah.
Saying the soil determines about how long maybe the construction will last. Then as we talked on also about water.
Yeah.
Water, okay. As well as water determining the skin, or rather the appearance of the concrete. The overview was just fantastic. So, regardless of actually being connected, very much connected 30 minutes after. We are connected, I think, at 1939, somewhere there. The other part, we could not get you clearly because we are going off network.
Oh, sorry.
Yeah, so we are very much connected 30 minutes after. So, but I've heard the overview.
Okay.
Fantastic explanation was very much good. The overview actually rather, because you said you did not introduce and you did not have any topic, because if you had a topic, I think we wouldn't have heard you clearly, because surely we are getting off network.
Okay.
And I think your overview was just clear to us.
Amen.
Okay, good. Well, there's a positive to be taken from that then. And they're quite vast topics. So if I just talk at you about a topic, I don't know how much people what they're struggling with, what's a challenge, or what they're really being responsive to. So I don't know.
I think
I'm very
what we can
I'm
do.
conscious of making sure that people
Yeah.
understand what's going on. But just to quickly address what you were talking about, yeah, with the soil kind of the technical elements of the soil, it will be really to do with gauging how long it will take in terms of the hardness of the ground, whether there's lots of rocks and boulders and things, but also how deep you need to go depending on the soil type, and what are the considerations in terms of what foundational types should you use. If you've got a very high water table, then you're going to have to dig really deep to try and accommodate that, or you're going to have to dig wide and kind of make a raft foundation. So there's different things that come into play depending on what the reality on the ground is. Excuse the pun. So yeah, that's it. So that will be covered in the course. Yeah, I'm looking forward to coming and getting things moving.
Amen.
Excellent.
We bless God.
I also have a question.
Yeah.
You can clarify on, on the double-story buildings.
Yes.
You also mentioned the wafers. Yeah.
Yeah.
I suppose it's them things that you put in the in the roof.
Yeah.
They look pretty heavy. Those ones I've seen.
22 kilograms.
Yes.
Give or take.
Yeah. How would you ensure that they stick up in the roof?
Yeah, you need to prop them from underneath. You need to make sure they're properly supported with like I've seen bamboo being used for it. I wasn't involved in that project myself. The ones that I've been with have used metal scaffolding sort of thing underneath. You cast your concrete. You make sure it's properly consolidated into all the voids, into the valleys that were created, and then you make sure it's all smoothly cast out, and then you let it set. You'll need to let it set for like 2 weeks. I wouldn't touch it until at least 14 days. And then once that's done, you remove all your scaffolding, and then you have your waffle roof.
Perfect. Another one is, I know in Zambia, it's very commonplace. Many people don't have vibrating machines, but they still make bricks. You're aware of this?
Yeah.
Yeah. So the technology behind the vibration, I think, is quite interesting in terms of the strength. So you explain the actual advantage we will have in using the vibrating machine in producing all these products, which are otherwise still produced.
Yeah. Well, it happens. It happens. So what would happen without the vibration of the concrete is that a lack of consolidation would happen, which means that there will be gaps, there'll be voids. We call them voids. And that really, really weakens two different things. It weakens the it weakens the durability and the strength. And what happens is, on the microstructure of concrete, the cement particles, when they've had water attached to them, it starts hydrating. And what that does is it creates a byproduct, which is like this very strong glue, and it moves outwards like this, and moves outwards like this. So in the beginning, you need to consolidate and make everything as close as possible. So when this glue starts to come out like this, you call it a CSH gel, it will bind onto all the aggregates, the sand and the stone, and it'll properly lock into the particles. Oh, I'm running out of battery. I might need to plug in. So what will happen then is, once you've had this gel that's fully
Do you want to plug in?
Yeah, give me a moment.
Yeah. Ask us many questions so that we set the tone for the training.
Okay. I'm plugged in.
Carry on.
Yeah, so where was I? So once the consolidation of the vibration, so it's removing all the air, you can even see it if you've used the machine already. You can see in the concrete little bubbles appear on the surface. What that really is doing is it's getting rid of the air, and it's pushing things down, compacting it down, and making it very consolidated. And as I was talking about, the microstructure of the cement particles they expand, and they knit into each other, they glue into each other. So what will happen then is if you put a load into it, you put some force into it, through the microstructures, it will move. It will move through this gel that's knitted into the next one, and it will move through them. And the more of these pathways you can give for the load to move through your structure, through your concrete, the stronger it will be. The compressive strength will be much better because of this. If you don't, the roadside blocks, which aren't properly done, and they're just kind of put in, and they're kind of like, I've seen them being hit a couple of times, and then that's it done. You're not consolidating it. So when the gels are expanding off the cement particles, when they're hydrating, they won't knit as well. There might be some that have missed, and then even though they're using the same cement, even though there's the same recipe, they'll have missed. So then when you're putting a load through it, it won't connect. So we'll need to find another route, and that's what will create cracks. And the second part of that is durability. So that means you've not vibrated it down for the compaction sort of thing, and you've created where those particles haven't knitted together, you've got a gap and a space. And what that will do is it will allow water to travel easily through your concrete and bring all the bad things with it that happens with water. The water, when it gets hotter, it expands. Like when you're boiling your water, it gets a bit, it's more energetic, and it will start to weaken your concrete, and it will slowly start to weaken your durability. So I'm not sure what temperatures become in Zambia, but if it gets below 0, you get a freeze thaw cracking cycle, which means that when the water gets too cold, it starts to expand, it starts to freeze, and then that will start to create micro cracks in your concrete. And then when it dries, when it gets warmer, the water will melt, and then they'll put more water in, and then you'll just slowly start to break up from the inside. That's one thing that happens. Another thing happens is it brings in some more chemicals into your concrete. And I'd say the most killer part of having these structures is of having badly vibrated, badly consolidated concrete is that your metal is then exposed because the water can travel through the concrete very easily. You've not given it any strength against the water. We call this permeability. If it's too permeable, it will just suck in water. It's very porous, like a sponge. And that's not what you want your concrete to be doing. So there's a lot of reasons why vibration is better than not vibration. But I understand why people do it, because they need to make a living at the same time. So things like the curing process on caring for the concrete after it's been produced. Now that is just knowledge that can be done by anybody who can put in some infrastructure to try and build, put some sort of water tank in, or even dig a pit like a reservoir and then screed the inside of it. During the rainy season, you get your water in there, and then you can use that to then keep your concrete nice and wet, or even submerge fully your concrete products. There's lots of different ways to do it. So there's things that can be taught to people, and they can instantly start implementing changes which will benefit their final product, and they'll make it more competitive in the market, so people can then start buying from them more. They build up a reputation. Things like covering it as well is annoying. It can be, there's different technologies I can put into play, or techniques more than technologies, where you can build up lines with perforated hoses and you can turn on a tap. So what that does is it will streamline the process, and then you don't have to individually put water on each single block, or things like this. Because yeah, it's been a learning curve for me as well. This whole journey is a learning curve. But yeah, there's things we can do to make sure that our vibration machine and the products it makes is the best on the market. So
perfect. Questions, additions, share experiences. We've got this my time. Yes, we've got 20 minutes more. Share your experiences. There's somebody under the on Galax call unable to interact. Would you know who that is, Webster?
Yes, please. Yes, please. We have Pastor Ken, Pastor Benson, and also Pastor Kambobe. They called. They were complaining about the network is bad. They're unable to listen properly. So they called. They wanted to find out what's the problem. And then I told them to say even us here, we have that same problem of network.
Okay, at least we're recording the follow-up. Perfect. So your team can go ahead and continue interacting and asking questions.
Amen.
Arthur is here now. Let's make sure that we learn a lot. Even in this first introduction, there's a lot to learn.
Yeah.
Go ahead.
Yeah, sorry, sir. I wanted to find out about the concrete.
Yes.
Yes. Although we are not clearly understanding, but I heard about the pouring of concrete. What measure
Okay.
about the strong concrete, or what measure of concrete and
So,
and the water, and because you said if we put concrete and then after that we can put water.
yes, curing.
Mhm.
Depending on its state, what state of setting it's at. Yeah. Okay. So I think there's two things that you're kind of alluding to there, from my understanding. One being, what's the ingredients for strong concrete? And the simple answer to that is we engineer the concrete depending on what it needs to be used for. So there's no point making really, really strong concrete with like a high grade of mix, when it's for a garden wall, you know? But as long as you know what the mix ratio, which is we'll be talking about the mix ratio in quite a lot of detail. The one we use is it's graded at an M20, which is a 245, which means we'll be using 2 cement, 4 sand or fine aggregate, and then 5 coarse aggregate. The reason we have slightly more sand than we do gravel or aggregate, coarse aggregate, would be because it helps the molding of the concrete. It helps it slip into place without too much of a reduction in strength. So that's one part of the ingredients. The second part is the water ratio. So making sure the water content isn't too high. So that ranges from about, if you can get it down to 0.35, which you can't really do unless you're making it like on a factory scale, like it takes a lot of mixing and a lot of agitating to get a 0.35 water ratio, but up to about a 0.5. So that means for every or 0.7 on the field. It depends what mixing apparatus you have. But but let's say 0.5 for this example. So if you have 1 kilogram of cement, that means you'll be putting in 500 grams of water. That would be the ratio that we'll be doing. In terms of the mix ratio, how you do that is you batch it. You can batch it either by volume or weight. Volume is quicker, weight is way more accurate. So what we can do is we can weigh it with some scales, some measuring apparatus on the field, and we can weigh it to get the correct ratio off the weight, and then we can create containers that are relative to that product, because 1 bucket of sand weighs more than 1 bucket of rocks, or 1 bucket of water will weigh less than, you know, they're different in terms of the weights and the volume. That's all to do with the density of what they are. But as long as you're keeping that ratio, you won't go too far wrong. Volume is probably sufficient. You can do batching by volume, which is just putting it, like, say it's a 245, you do 2 buckets of cement, 4 buckets of sand, 5 buckets of your rock or your crushed stone, whatever. So volume, I've used volume in the past, but if you're going to be doing this for the mass market, I would be saying, if you're going to create this as a business, all you're doing is putting in another step to make a better product. You just need to take the time to weigh things. So that means that when you're doing your buckets, you need to work out the weight difference compared to how that relates to the volume of the material, and then create buckets corresponding to that. So that's something we'll look at as well. In terms of the water ratio, the reason why we want to keep that low, the lower the water ratio, the better the concrete is, the stronger it is in terms of strength and durability. Now, the problem is what you really want to do is, in the ideal world, the science world, is to get every single cement particle with a coating of water around it, and then that's it. That's all you want. Any extra water is actually detrimental. It's bad. It's bad for the concrete. But to do that in practice, it's very hard to do. So there's a trade-off between the theoretical and the practical. But at 0.5, you don't really want to go much more than 0.5 with your water. And the reason being is once that water dries up, you'll be creating weaknesses. You're doing two things. You're making a less dense product because you'll put more water in it in the beginning. So when it dries, then those voids, those gaps that the water will have left will create capillaries like tunnels, like pores in the skin when you sweat, but going the other way, where water can then pull into it. So it will damage the durability, not only of the concrete, any of the metal reinforcement bars you have inside the concrete, and it will also it will leave it susceptible to chemical attacks and things like this. So yeah, it's a lot to do with the durability, but also with the strength. So we want to try and minimize that concrete, the water ratio in our concrete, and we want to try and cure it properly. So there's a few different phrases that you'll be learning over the course. I'll be using over and over again. Things like longer is stronger. So the longer you can leave your concrete curing is better. And if it dries, it dies, and that's true. If you stopped putting water on it, because what will happen is, I'll get into this to a point. When the water hits the cement, it starts to hydrate. It's an exothermic, which means it's a hot reaction. So if you feel concrete when it's just been laid, or just after it's set, it's hot. I don't know if you get to really understand that, because it's so hot in Zambia anyway that maybe it's not easy to tell. But concrete creates heat when it's cooking, or it's going under the hydration reaction. So what will happen is the water, you put it in your mix, and that will react with the cement to create the secondary product. And once that's used, once that water is then used, once it's set, that's what you want. You want to put in the exact amount of water to create the gel, the CSH gel that's around the cement. And once it's set and can no longer take in more water, that's when you want to start putting it in the curing stage. So what that means is every time it wants to start knitting and tighter in with its existing cement particles, it has water to access, because if it's dry, then it will die. The whole reaction will stop. So what will happen, as I said, 28 days is really when concrete is going through this hydration process. Even though it might be solid and you can walk on it in like a few days or a week or whatever it might be, it still wants to go through that process of hydration. But if you're not giving it water, it won't. It will no longer hydrate. So that's where the curing comes in. So you're feeding it. You're kind of like feeding it like a plant, I guess you could look at it like. Instead of just seeing a plant in its baby form like that and saying, okay, it's done, let's walk away. I've made a plant. It's good enough. All I wanted was a plant. What you really need to do is just you keep feeding it water, and then it gets bigger, and then it gives you a final product much better. The problem with concrete is you can't immediately see that it's not good quality concrete because you've skipped some corners in the curing procedures. You find out like maybe 6 months, a year, 2 years, 3 years down the line, when you could have made something that would last 100 years. It lasts instead like 4 or 5 years. We're going to try and.
Sorry, Arthur. Sorry. Unmute yourself. I made a mistake. Sorry.
No problem.
Go ahead.
No problem. Yeah, but you cut me off at the perfect time, because that was sort of just getting into the chemical process of how concrete gets its strength, which is just yeah, if it dries, it dies when it's in its curing state, when it's in its hardening state. And yeah, the longer you can leave it, the stronger it will get, as long as it's in high water conditions, humid conditions, and it's covered from direct sunlight.
Amen.
Perfect.
Well,
Go ahead.
yes, sir. You're muted. Hello?
Yeah, you can talk. Yeah, no, please go ahead.
Yeah, yes, please. Well understood. We are learning. Amen. Yes, my question is that is it possible to make concrete using building sand?
Okay.
The situation whereby you don't have river sand and stones, is it possible to make concrete using building sand?
You can use, it's not ideal. It's too, like, it depends on the purpose, is what I'd say. is if you're going to be using it as a foundation for a building, I'd say no. You need sharp sand. You need proper graded, like sharp sand, something like 2 mils or something like that. Like, because otherwise it's so thin that it can slip. It slips between the stone. When this goes back into the engineering side of it, when the stone is experiencing force in the concrete, it's not bound as tightly as it should be because of there's not enough friction created by like coarser sand. So I would say, look, I'm a realist. I've worked in India and Africa and kind of all over the world. I understand that not all products, not all the ideal products are available. Not materials might not be there. There might be shortages, things and things. So all I'm going to do in the process of this course is say my knowledge, but then I completely understand that it might not be realistic on the ground. But then I will say, maybe just make, instead of going for like a 5-inch slab or a 4-inch slab, maybe make it like 4.5 or 6 inches if you're not. But so I'm giving you the knowledge to, you can make these decisions then. You can then understand what can be done and work with the resources you're given on the ground. So that's you can use it. It depends what it's for. Is what I would say.
We bless God. I've asked this question because in Zambia, in Mongo, to be specific, in Mongo, they use building to make concrete, and when they are doing floor, they use building sand. So
Yeah,
that's
well, the slab they were doing, the 6-inch slab they were doing with building sand, or the screed, because they're two different things. There's so many different elements to the building. Like a finishing layer, like a decorative layer, that's fine. Like the finer sand is actually better to use because you get a nicer, smoother finish where it's not as like water doesn't penetrate as much. Like plaster, things like this, you would use a finer sand, but with the pour of the concrete, when you're doing the sort of, you're pouring your slabs or you're doing any of your sub like grade, your sub bases, things like that, you want to be pouring in stronger stuff because it's going to, all the load is going to be going through it. But so it again, it depends on what it would be for.
Amen. Now, about river sand without stones, only river sand make a concrete. Is it okay?
So is it sharper sand? We talk about sand in terms of grading. There's lots of different names to it. Is it fine or is it sharp?
Fine, fine one. I mean, there is a building sand and also a river sand. A river sand has got small grains.
Okay,
a river sand has small grains, yes.
Okay. So you're gonna have to forgive me because there's a lot of different local names for building products. When I first went, I had a project in India recently when they called blue metal. They're talking about blue metal, and I was saying, "What's blue metal?" And it was confusing me. And what it is, it's what they call the rocks. They call the granite rocks that we were using. They call it blue metal. So over here in the UK, we call building sand the very, very fine sand. Building sand for us is the stuff that you would use for like mortar and things like that, or things that you would use for like the finishing. Whereas like river sand for us is sharper stuff. It's rougher than the building sand. So you're telling me that from my understanding, you can correct me if I'm wrong, please. That river sand is finer than your building sand on your side.
No, building sand is fine than river sand. River sand has small grains. It has grains.
Yeah. So I think that's the same then. So I would use your river sand. River sand can be used for concrete production, for the superstructure of the concrete, for sure.
Perfect. Excellent. Oh, wonderful session. I think we learned a lot from the overview. This is very good, and I'm excited, super excited that this is going to be a wonderful selling team, and we have men of knowledge. I like the depth of your knowledge just from the overview, Arthur. I know that you know stuff. You're really deep. It's a blessing to have you
Enjoy
on
it.
board. And
Yeah.
by the time that you get to Zambia, you're gonna make our people fly high. You're gonna see a different Zambia than you saw it many years ago.
I hope so, man. I love the country.
It's
Country.
lovely. The infrastructure itself is beautiful now, much better, much excellent. You'll be lost. I was lost myself last year when there, and I said, "Wow, this is good."
Really? Oh, cool.
I was lost. I'm telling you, I had to use GPS for the first time. Good. So I think we have gotten the overview of what we're learning, and we'll schedule another session where we can focus on one aspect. The session is recorded. I'll make it available to the students. I've already created an account for them where they can log into and listen to these sessions again. I want them to be grounded in theory, which is an asset having you here. And I'm also learning a lot. So I will collaborate just by WhatsApp and talk more.
Yeah, we'll talk after this for sure.
Yes. But thank you so much for spending this time. And I hope you won't catch a wrong train. So I'll officially stop recording. I just want to give 2 remarks before I stop officially recording. Arthur, any remarks? Conclusion?
No, I think this was a very positive kind of meeting and an overview of what's going to happen, what the course entails. And it's nice to finally put some voices to the names that you've been talking so highly about. So yeah, I'm looking forward to moving forward.
Thank you very much.